input, no problem. It will still work because I am not connecting the Arduino for my power supply for 5 volt, but I am connecting this port, which is USB A type, to my laptop. For step 1, we have to take the breadboard and the ultrasonic sensor, and we have to connect the ultrasonic sensor to the breadboard, and it will look like this. And from the back, the ultrasonic sensor has 4 pins.
This one, and the second is the trigger. The third is echo.
VCC will be connected to the 5 volt on the Arduino, and this is the trigger. Trigger means it will send the ultrasonic waves to the target, and then the waves will reflect back, and the waves will be absorbed by this. This is known as echo. And trigger and echo will be connected to the digital ground. Will be connected to the ground on the Arduino. Might be a little confusing for you all to recognize if this is the trigger or if this is the echo. Trigger means it will send the ultrasonic waves and echo will receive them. So trigger is the transmitter and the echo is the receiver. There is a shortcut way. See, this is the trigger pin, and beneath this it is written T. T means for transmission, and this is the echo. Below this it is written R. R means for receiving. So the next step is we have to connect the ultrasonic sensor to the Arduino board. So as I mentioned previously, sequence from VCC, trigger, echo and ground. So I will remember them and connect. VCC will be connected to the 5 volt. So I will connect to this is the VCC pin and connect it over right here. And VCC will be connected to the 5 volt on Arduino. So the 5 volt
over there. We are in ground out, and this is the 5.
So it will be connected to here. And the next step, we have to connect the trigger. This is the trigger. We can connect trigger pin to any of the digital pins on the Arduino. The digital pins are, let's say I am connecting the
These are PWM pins. See. With this type mark. After that, we don't have to connect the trigger and echo pin to PWM pins.
I am connecting them. I will connect the pin. Echo pin to the pin number 4 is not the PWM. So I will connect it to here. And so the last is the ground pin. So we will connect. And on the Arduino, the ground pin is right over there. It is there also, but the wire is not so long. So I am connected it here only. So ultrasonic sensor is fully connected with the Arduino. To connect the LEDs to the Arduino.
So I will take an LED.
So the longer wire is the positive wire and the shorter wire is the negative wire. Connect it here. And I will take one resistor. Resistor have one is the white color type and the other is brown colors. So we have to connect the white color to the positive wire. The positive wire is here. The ground pin on Arduino is the negative wire. Connect the positive wire of the LED to any of the digital pins. Take one jumper wire.
And this is the port. So I will connect it here. And the other side, let's say I am connecting it. I don't have to connect them to the PWM pin, so I'll connect them to 7. Pin number 7.
This is the negative terminal. So I'll connect it to the ground pin on the Arduino. So on the Arduino, the ground is right there. And I'm taking another LED which is of the red color. This one. So we have to follow the same procedure with it. Take the resistor. Connect the negative pin of the LED to the ground pin on the Arduino.
So I have connected the negative pin to the negative pin of the LED to the ground pin. So I will connect. So now I will connect the resistor pin to any of the digital pins. So see 8, the pin number 8 is not a PWM, so I will connect it to this.
So our full setup is complete of connecting the ultrasonic sensor to the Arduino, and I have also connected two LEDs.
The range of ultrasonic sensor is too far, and the red LED will blink when the range comes close. So now let's go to the programming part. So to take the wire, and this one port will be connected to the Arduino, and the other port will be connected to the laptop's cable. So let's connect this to the Arduino.
Another one. So let's come to the explanation part. So in the first, I have defined trigger pin. Trigger pin of the ultrasonic sensor is pin number 2 on the digital pins. and the echo pin is pin number 4, and we have made an integer LED. It will define LED is at pin number 7 and the LED 1, which is of red color, is at pin number 8. And we have printed integer. We have made an integer duration and a long distance. Distance from the sensor might not be as accurate, so it will be stored as in a form of double. So double means decimal values up to 8 points. So but we have made an integer, so the values on the serial monitor will come as an integer form but not as a double. Trigger is output. It will send the ultrasonic waves and echo will receive them. Echo means input. LED and LED 1 means green. This is the green and this is the red. So green is the output and red is also the output. So this is a serial.begin 9600. This is the serial name. So we have to begin the serial. Loop means the portion below this will keep on running again and again. So for delay microseconds, for 2 microseconds, the trigger pin will be low. Trigger will be low, meaning it will not send any ultrasonic waves. And for the next 10 seconds, it will send an ultrasonic. After delay of 2 microseconds, the ultrasonic sensor will send the ultrasonic waves through the trigger pin for 10 microseconds. After that, we have lowered the trigger pin, and the duration is pulse in echo high, meaning the echo pin will receive the ultrasonic waves that will come to it, and distance will be duration upon 2 multiplied by 0.343. So we are calculating duration upon 2 because
this is the ultrasonic sensor and this is the trigger, and this will be the echo. When the trigger will send the waves, see, meaning this is the target, and the rays will hit it, and then
the time it will take for the waves to go. So we will let the time taken be A. So the time A, this be the time. So the time is for going and coming back waves. So when we will divide A by 2, the time taken will only be of the sending waves. So that's why we have divide by 2. So after that, we have written serial.print distance, meaning it will print distance of the serial monitor, and then distance. The distance is duration upon 2. This will be printed after that, after distance. And serial.print ln. ln is used to break line. After printing this, it will break a line. The next value will be printed on another line. So I have written if distance is less than 40 centimeter and greater than 0 centimeter, so the LED one, which is of red color, will be high, and if delay of 20 milliseconds, and after being high, it will again low, and the delay of 20 milliseconds. So meaning this is the code for blinking the red LED 20 milliseconds. Duration of, so I have written the code, same codes again and again for the different values, and after the value does not agree with any of the statements, the else loop will work. So in the else I have written digital light LED low, and after that digital light LED 1 low, meaning the green and red LEDs, if the range is not 2 meters, the LED will be low. It is very far distance, the green LED the very less time interval.
When we click on the serial monitor button, a serial monitor appears, and in that we are able to see the distance of the room. See, when I place my hand in front of it, the distance starts coming. See, when I place my hand in the distance, so see, the values start coming fast and they are in a less distance. We can measure any distance using this ultrasonic sensor. See, the distance from the sensor and me is coming approximately 34 centimeter. So the distance of the room is to the wall. The upper side of the
from my table is coming 80 centimeter. So we can measure any distance using this sensor.